and let's go off. Hello everyone, I want to ask you about something. What do you know about F1? Because from an outsider's point of view, you could say that they are a bunch of cars running around in weird shapes. But actually, those cars are the titans of engineering. F1 wasn't the first motorsport, given that its first world championship happened in 1950 and car races went back 30 years prior. But we don't want to get that much into history. Let's get to the interesting part. We all know cars are supposed to go fast, and to do that, they need to be light. Actually, weight is one of the most vital aspects of the car. It allows the car to take curves easier and to turn more precisely. It also spends less fuel and the tires wear less, but of course, it's not all about that. It is also about aerodynamics.
The car is divided in parts, one of which is the nosebox. The nosebox is designed with a thin and long form, so when the car comes at great speed and the air causes turbulence, the nosebox cuts the air into two parts, making it flow orderly. Also, this air that is divided goes to the front wing, which also divides the air. The air that go to the top of the car makes an effect that we call downforce. This means that the car is pushed down by the air, so it sticks to the ground since it's lightweight plus the speed that lifts the car. There is also another effect called ground effect, which is like sucking the car to the ground. The floor of the car is designed in a way that the air passes fast, so the air that goes under the car kinda sucks it into the ground. As a consequence, there's no need to use bigger front wings that could slow down the car.
The ground effect happens mostly thanks to the rear diffuser, which is placed under the car. It is a tunnel that has elevations that help the air go faster. When it reaches the diffuser, that air expands and decelerates. However, in doing so, it creates a low pressure zone just below the car. It is like when you press a hose, the water comes out faster until you stop pressing it. It is the same as when the tunnels are narrower, the air comes out faster. Let's move on to the rear wing, which honestly does almost the same as the front wing. Its inverted wing shape allows the car to be pushed down. Here we see the downforce effect again. The difference between the front wing and the rear wing is that the rear wing has an extra function, the DRS. DRS stands for Drag Reduction System. It can only be applied in certain parts of the track, and it allows the driver to open a part of the rear wing to go faster. However, it is only allowed in certain zones because it makes the car lose force. It can only be used when there is less than a second between two cars.
Let's talk about one of the most fascinating battles happening on a Formula One single-seater, not between the drivers, but between air and engineering. As the car slices through the air at over 300 kilometers per hour, one of the biggest troublemakers for aerodynamics performance are the wheels and tires. Yes, those spinning rubble circles kick up chaotic dirty air like smoke in a kitchen. That's turbulent and unpredictable. It's not the kind of air you want flowing over the rest of the car. To deal with this, F1 cars are equipped with something called barge boards, just behind the front tires. They push all the dirty, unwanted air away from the car's body and direct to the clean, useful air where it needs to go. That clean air gets channeled into the side pods, which act like the car's lungs. This helps cool the engine and other critical components. It flows through the car and exits out the back, just beneath the rear wing.
Now, let's talk about the structure. Unlike road cars, there is no separated chassis or frame. Instead, F1 cars use a monocoque, a strong carbon fiber shell that includes the cockpit. The engine, gearbox, and monocoque all combine to form the backbone of the car, like a human skeleton with muscles and organs built right into it. Inside that base of a machine is a V6 engine with tiny flat pistons built to scream up to 15,000 RPMs. Now picture this. Those pistons are firing so fast. It's like a drummer hitting the snare 2050 times every second. And what happens to all that hot exhaust air? It gets routed to a giant turbocharger, a bit like recycling the engine's breath to give it even more power. The turbine wheel spins from the heat, which then drives a front-mounted compressor that sucks in more air to feed the engine. That compressed air gets too hot, so it travels to a giant intercooler in one of the side pods, when it's cooled down by the rushing air outside the car.
From there, the now chilled, dense air is sent to intake plenums, special air chambers designed to make sure each cylinder gets its fair share. Inside those plenums are intake trumpets. Think of them like musical instruments. each tuned just right to deliver a perfect blast of air to each cylinder at exactly the right time.
These aren't just cars running around. These are parts of the piece of art that this single-seater is. Every screw counts. Every engineer counts. Every person that has spent a part of their life working for this counts. These cars aren't just machines. They are proof of love, passion, and hard work for something as simple as entertaining.